Okay, so you can consider this last example here to be your challenge problem. I want you to think through the steps, what you'd have to do to try and solve this one. The only hint I'm going to give you right now is that, remember, if it has an x-intercept at 2 minus root 3, if that came from the quadratic formula, you also have to have one at 2 plus root 3 as well. So you got two x-intercepts, one at 2 minus root 3, one at 2 plus root 3. Giving you the fact that the optimal value of the function is at 9, and I want you to find f inverse at negative 18. So I want you to think through this one either on your own or with a partner, and when you're ready, push play to get an answer. Okay, so lots going on here. I just want to show you a couple of different approaches you can take to this problem. The first thing I did is I had the optimal value of 9, and I had two x-intercepts, so I figured I'd at least start by finding the axis of symmetry. Because that does a couple of things. It gives me axis of symmetry, it gives me the x value of the vertex, which combined with the optimal value would give me the y value, so I could actually have the vertex. That's a nice point I can use. So I took my two x-intercepts, 2 plus root 3 and 2 minus root 3, add them together, divided by 2. The root 3's cancel nicely up here, so you wind up with an axis symmetry of 2. So that gives me a vertex of 2, 9. And this is where the approach that you take might have been a little bit different. One thing you can do is if you have the two x-intercepts, you can do what we did a couple of examples ago and start by building factored form. So I get f of x equals some a value, x minus bracket 2 minus root 3, and x minus bracket 2 plus root 3, which simplifies down when you run that negative through the brackets. And then you could sub in a point that you have, which now we have the vertex, sub that in for x and y. So putting in x equals 2, y equals 9, going through the math and algebra from there, simplifying and solving for the a value. And then once you're finished, you have an equation in factored form. Okay, so that worked reasonably well. It took a little bit of work, but we got there. The other approach you could take instead, and again, you might find this easier, is once you have the vertex, forget factored form and just try and build that one. So if the vertex is 2, 9, I can build f of x equals a bracket x minus 2 squared plus 9. And I need to sub in a point to solve for a. I've already used the vertex, now I have to use one of my x-intercepts. So I can choose either one of these two x-intercepts. I chose 2 plus root 3. So 2 plus root 3 goes in the equation for x. 0 goes in the equation for y, or f of x. And again, once you have that, you'll see that here, in this case, inside the bracket, 2 minus 2, those cancel out, so you're left with root 3 squared, which is just 3, and you can solve that equation for a, and again get the equation vertex form. So two different approaches, they both work, it's just a matter of where we go from here. Because remember, we're not actually looking for f of x, we're looking for f inverse of negative 18, which means it's the x value in the inverse or the y value in the original function. So I'm trying to solve f of x equals negative 18, really. Okay, and looking at both these forms, you might wonder, well, which one do you think is easier to solve? In my opinion, this second one is a lot easier to solve because, again, since it's vertex form, there's only one instance of x, so we could actually solve it. If I were to use this one, put in negative 18 for y, I would have to expand all this out, put it into standard form, bring the minus 18 over to the right side, and then either factor or use quadratic formula to get my answer. While I certainly could do that, it's a lot easier to work with vertex form. So whatever method you chose is fine. Just keep in mind that there often is a faster way, so just try and think through the problem first. So I'm going to do the vertex form approach here. So we'll put in negative 18 for y. So it'll be step 3. Okay, so bring the 9 over, I get negative 27. Okay, divide both sides of the equation by negative 3, I get 9. Square root will give me plus or minus 3 on the left side of the equation. So that gives me two solutions. So I wind up with x being equal to plus or minus 3 minus 2. So that means that x equals positive 3 minus 2, which is 1, or negative 3 minus 2, which is negative 5. So I got two possible answers there. Okay, so again, if you're using vertex form, it's not too bad. If you're trying to use factored form, you'll find it takes a few extra steps to get there. So if you try this one, you don't get the same answer as I got down here. Do ask me, and I'll run through the steps with you and see where we might have made a mistake. But other than that, I think we're good to go. So your homework's there. Good luck with it, and let me know if you have any questions. Thanks a lot.